Howdy, I'm Meadow Reynolds, and today I will be demonstrating the Chatelier's principle on equilibrium shifts with Br2 gas, CO2 gas, and COBr2 gas. We will start on the product side. Let's say we add products to the product side, COBr2. Obviously you have more there, therefore the equilibrium will shift that way, therefore favoring reactants. As you see, now they are balanced out. For a better size demonstration, I will be using these. Of course, these would be different, but imagine these in there. So therefore, you add those, equilibrium shift, it is completely equal. Now going over subtraction, let's say I took out some CO2, all right? So you're taking out CO2, well then there's more over here and there's still some here, so the equilibrium will shift this way in order to balance this one out. So therefore, taking less of that. So even though I showed subtraction over here and addition over here, if I were to flip it and add over here, the equilibrium would shift this way, seeing as you're now adding it and it needs to shift to balance out. If I took subtraction over here instead of over here, then obviously the equation would shift that way as well, seeing as there would be less product over here, creating a balanced equation on both sides. So flip-flopped or the way I did it, same thing. For exothermic reactions, heat will be released. Therefore, the heat being on that side will cause the equilibrium to shift this way. Now, with an absence of heat, the equilibrium will shift the other way, and vice versa for endothermic reactions. Heat being added to this side of the equation will cause the equilibrium to shift this direction. Heat being taken away will cause the equilibrium to be shifted this way. Now for the addition of pressure, if pressure were to increase, so the Chatelier's principle states that it will favor the side with fewer moles of gas. Now there is 1 mole of gas over here where there's 2 moles of gas over here, therefore the reaction will shift to the fewer moles of gas, shifting this way. If pressure is decreased, as so, the reaction will shift towards the side with more moles of gas, so therefore the reaction will shift this way. And that is the demonstration of equilibrium shifts given the Chatelier's principle. I hope y'all enjoyed.